Welcome to lesson 8.2, absolute value functions. I'm sorry I couldn't be here today with you guys. What I'd like you to do first is work on the bell ringer. So pause the video and work on that for me, please. All right, welcome back. You should have gotten the solutions were 2, 4, and -1, 1 when you graphed them. So the first one was a quadratic equation. The second one was a linear function. And the 2 points that they intersect were 2, 4, and -1, 1. All right, so our objective for today is to solve systems of linear and quadratic equations graphically. So the first thing that we talk about is the absolute value function. And we've seen absolute value before, right? We know that it is the distance away from 0, right? That's what it calculates. So if you're a negative number, we instantly know that you turn positive because distance is always positive. So the absolute value function is the distance from 0 on a number line. And the function, when graphed, it creates sort of like a V, right? Because if you think about it, what we'll talk about in a moment is that -2 and 2, their absolute values are the same, right? So as you can imagine, when we graph them, it'll be the same on both the left and the right. So it'll be kind of a symmetric graph, rather. So remember, absolute value function takes a number, calculates it as the distance away from 0 on a number line, and it creates a V. Okay, so let's look at a couple of examples to have us remind what an absolute value function is. So here we go, right? The absolute value of 13 is 13, right? It's 13 away from 0, as well as the absolute value of -13. It makes it positive because it's the distance away from 0, which is 13. Same thing with -2 and +2. We see that their absolute values are exactly the same because they're the same distance away from 0, right? So the absolute value function takes two different inputs and gives it the same output. Okay, so why don't you flip the page for me, please? All right, so our first thing that we're going to do today is graph this function right here. So remember, this is a piecewise function. This is telling me when x is less than 0, we're going to plug in our x value, multiply it by a -1 to get our y value. Right? So I'm going to create a table here to sort of help me. All right, so when x is less than 0, remember it also includes 0. Okay, but remember it's going to be an open circle at 0. So I'm going to do 0. Let's see, -1, -2, -3. That looks good. All right, so when x is 0, if I plug this in, well, 0 times -1 is still 0. So when x is 0, my y, or rather my f of x, right, is also going to be 0. Next, I have x is -1, so I'm going to take -1 times -1, right? This is the same thing as -1, and then if I put in parentheses -1, that gives me a +1. Here, if I plug in -2, it's going to be a -2, which makes it a +2. And for 3, it's going to be plugging it in here, minus a -3, which is a +3. So when x is less than 0, it seems to look like we have our 0, 0 here. Remember, it's open because it is not included there. We have a -1, 1, which is closed, -2, 2, -3, 3, and it will keep going in this fashion, right? The entire way. There's no limits on our domain, so make sure we put our arrow there. Okay. Now for our next one, it's pretty easy to get this table, right? When x is 0 or more, that means that our y is going to be our x. Right? So if we start at 0, 1, 2, 3, let's say. So when x is 0 here, that means y is also 0. When x is 1, that means y is also 1. They're the same, right? Same thing with 2 and with 3, right? This tells me that y is whatever x is. They're the same thing. So because this is for x greater than or equal to 0, that means that it includes this. So on 0, 0, I can fill this in. Then I have a 1, 1, a 2, 2, and a 3, 3. And again, there's no limitations, right, on how far I can go with that because it's for all x greater than or equal to 0. So that's why I have to put that arrow there. Okay. So now if we look at the next part, what we're going to do is graph the absolute value function. So how do we do that? Well, first let's get our calculator out. Boom. All right, here, I'm going to open it up. Remember, you're going to hit your y equals to graph. Now, when you do this, you're going to hit math, which is right here below the alpha. So you're going to hit math. And if you go over to number, this abs tells me I'm going to take the absolute value of something. So I'm going to click that. And my absolute value function, remember, is y, or f of x, equals the absolute value of x. So it's going to look just like that. So I'll repeat that for you if you need to. You're going to hit math, go over to number, hit absolute value, and then enter your x in there. So then to graph this, you're going to hit second table. I want you to take a moment to graph this function, please. Find out what f of -1 is and what f of 1 is, and over what domain interval is the function increasing. Okay, I want you to take a moment, pause the video, and do those things for me right here. All right, welcome back. You should have got something very, very similar to mine. Right, it looks just like this here. So I still have my arrows on both ends because my domain is all real numbers. 1 and 1. And if we look down below here, the domain in which it's increasing, well, it's increasing from 0 onward. So I put including 0 all the way to positive infinity, or that's really all non-negative real numbers, right? All right, perfect. So go ahead now and flip the page for me. All right, so now we have this right here where it says, consider the absolute value function f of x equals x plus 3 only on the interval from -6 to 2. It wants us to evaluate f of -5 and f of 2 without using a calculator. All right, so first I'll do f of -5, right? That means I'm going to plug in -5 wherever I see an x. So that's going to equal, it looks like I have the absolute value of -5 plus 3. Well, remember, when I evaluate with an absolute value function, I do what's inside the absolute value first. So -5 plus 3 is -2. The absolute value of -2 is 2. Right? I want you to do the same thing and find what f of 2 is. So plug 2 in for x here and see what we get as our output. Then what I would like you to do is graph this equation and look at the table. Okay, so remember how you're going to do that this time is when you get to your calculator, you're going to do y equals. Now you could clear it if you want and go back to the math over to number and hit 1 for absolute value, or you could just inside the parentheses highlight the x from the previous one and instead place x plus 3. That would be okay too. Remember, second graph to get the table. And I want you to graph it on the domain from -6 to 2. Also write the table on your paper for me, please. Notice that because it has a restricted domain, we are not putting arrows on our graph. Okay, after you do that, I want you to figure out on which interval is it always increasing. Circle the correct answer. And state the range of f of x on its domain interval. Okay, so go ahead and pause the video and do those things for me, please. All right, welcome back. Let's take a look at what you should have got. So here we go. Take a moment, pause, see if you have any questions here before we move on. All right, so now what we're going to do is we're going to rewrite our function and our graph. But how do we do that? So if we notice when we go back to the first example that we had, right, back to this piecewise function over here, we noticed that it was the exact same as the absolute value function. And what it is especially interesting to notice, I guess you could say, is that all of these negative values for x, right, for all x less than 0, it turned our function into the opposite, right, -x. So when I look here at this new one, when I write this as a piecewise function, if we look at our table up here, for all values less than -3, right, it takes all of those values and makes them positive, right? So it takes my negative 3 and makes it 0. Takes my negative 4 and makes it a positive 1. Negative 5 makes it a positive 2, and so on, right? So what that means in our piecewise function is that our function, for all values less than negative 3, the way we calculate that is negating our x plus 3, right? Taking the opposite of x plus 3. And when we do that, we really get f of x equals the set. This is really going to be negative x if I distribute this negative 1 minus 3 for all x less than negative 3. And then for all values where x is greater than negative 3, right, it's going to be the absolute same. If we notice, for all x values greater than negative 3, I don't even have to take the absolute value of those functions, right? Because when I plug in negative 2, I'll instantly get 1, which is already positive. If I plug in negative 1, I'll get 2 in my function, which is already positive, so I don't have to take the absolute value of that. Plug in 0, I get 3, which is already positive, so there's no need to even take the absolute value of that, and so on. But for these negative numbers here, like negative 4, for instance, when I plug in negative 4, I get negative 1, and I have to take the absolute value of that to get a positive 1. So in order to avoid the absolute value function, the best way to do it is to negate the function or multiply it by negative 1 on all intervals where it is less than negative 3. So I have it right here. But when we have x plus 3, that's when x is always greater than or equal to negative 3, which already turns positive like we just talked about. All right, so the key thing to remember here is that when we rewrite it as a piecewise function, for all values that are normally negative, so for all values on the left of the tip of the V, we need to negate what's inside the absolute value. And for all that are greater than the tip of the V for the x values, we keep it the exact same as what's inside the absolute value function. Okay? So from here, I want you to try to graph this and see what it looks like. So for all x less than negative 3, I want you to graph it. Same thing for x greater than or equal to negative 3 using this piecewise function, and see what you get. So pause the video and do that for me. All right, welcome back. You should have got the exact same graph as you did up here, right? The exact same one. So what this shows us is that we can take any absolute value function and make it into a piecewise function, which is pretty cool. So now I want you to flip the page for me. And let's take a look at our next couple examples. So for these two examples, what I would like you to do for each is take the equation, plug it into the calculator, graph it, find its domain and range, and then you're going to rewrite the function as a piecewise function, and I'll help you with this one. Okay, but our first goal is to graph it. Remember, there's no restriction on the domain or the range. So you're going to have to see what those two are based on your graph, and then we'll rewrite the function together. Okay, so why don't you do this first one, y equals the absolute value of x minus 5. Pause the video, do that, and then resume, and we'll talk about how to rewrite it. All right, welcome back. You should have got an equation that looked like this. Here's our graph, right? It looks like our v is at positive 5 here on our x value, and there's arrows in both directions. Our domain is all real numbers, right? Any x value works, but our range, be careful, the x values don't go any lower than 0. Sorry, the y values, Ms. Fall, don't go any lower than 0. So now when I rewrite that function, I have to think to myself, all right, well, f of x, which is our function, equals, so whenever x is less than 5, right, it's taking and it's using the absolute value rule, right? It's negating what's ever in there, right? So if I plugged in 4, for instance, I would get negative 1, but that negative 1 becomes positive 1. Same thing with 3. When I plug 3 and I get negative 2, but the absolute value makes it become positive 2. So what that's doing is it's taking whatever it is when I have x minus 5, and it's negating it. It's making it positive, right? So that means I'm going to put this negative in front because it's taking whatever I get and making it positive, which is the same thing as multiplying it by a -1. So that is when we have x is less than, looks like 5. But if x is greater than 5, we know that we don't even have to take the absolute value because it's already going to be positive. So we can use the equation x minus 5 for whenever x is greater than or equal to 5. Okay, and I wrote that down here for you nicer so you can see it. Okay, so now what I want you to do is try the same thing for the next one. See if you can rewrite the function on your own. Okay, so go ahead and pause the video and try the next one. All right, welcome back. Let's take a look at this next one here. We have y equals the absolute value of x plus 2. The domain is all real numbers. Range is the same. When we rewrite this, notice that it switches. Its point in which it changes is at x equals -2. So that means when all values of x are less than -2, it's going to take whatever is in the absolute value function and turn it positive, which is the same thing as multiplying by -1. So down here, we have that for all values of x less than -2, it's going to take whatever's in there and make it positive, which means we're multiplying it by -1. But for all values greater than or equal to -2, it's going to stay positive because it already was to begin with. So it's going to be x plus 2. Okay? All right, what I would like you to do now is flip the page for me. All right, we have 2 more examples very similar to the ones that you just did. Notice that this one has a restricted domain between -3 and 3, but this one does not. So I want you to try your hardest to work on these. I have full confidence in you that you can graph them, find the domain, and find the range. I know rewriting the function is new, and I'm not here to help you, and it's kind of hard to talk about it over a video, so try the best you can on it, okay? When you are done, you may hit resume on the video and check your answers. All right, welcome back. Let's take a look. Your graphs should look just like mine. So let's start with this first one here. It looks like the tip is at 3. Arrows on both ends because there's no restricted domain. We have all real numbers, and y is between 0 and positive infinity for our range. Rewriting the function, so it looks like when x is less than 3, that's when it changes our numbers from a negative to a positive with the absolute value function. So when x is less than 3, we have to multiply what's inside it by -1. But when x is greater than or equal to 3, like to the right, we see that we can use x minus 3, and we don't have to worry about the absolute value function. Okay? For the next one, you should have had no arrows on the end. Our domain was between -3 and 3. They gave it to us. Our range was between 0 and 6. And rewriting the function, we had to be extra careful because now for all x values between -3 and 0, we have to negate what's inside the absolute value function to make it positive. So it'd be -2x for those values that are to the left of our minimum. And for those that are positive, it would be between 0 and 3, which is going to give us our 2x. Okay? So once you've had time to sink this in, I want you to flip the page, and we'll get started on the next one. All right, so now let's take a look here. We say which function below correctly illustrates the absolute value function. So remember, the absolute value function can be written as a piecewise function, but we never use the square root in a piecewise function with the absolute value, so we can get rid of those two. So now we're down to 1 and 2. So 1 and 2, this tells me for every value less than or equal to 0, our absolute value function keeps it the same. So let's say this is a -1. That means if a is -1, then the absolute value of a is also -1. Well, that doesn't make sense, right? So that's out. Let's look at this one. This says for all a greater than or equal to 0, let's say 1. That means if a is 1, the absolute value of a is 1. That makes sense. Okay, let's try one for this one. This says when a is less than 0, let's say -2, means it takes -2 and multiplies it by -1, which gives me a +2, which is what the absolute value of -2 is. So I know that 2 is my correct answer. Okay, let's look at number 2. Number 2 says, which absolute value function is equivalent to this one here? So if we take a look, remember, for all x is greater than or equal to the number where our point gives us our v, that is the absolute value function, because all that are less than that point where v's off takes it and negates it and makes it the opposite, right? So if you can remember that for all positive values, or for all values greater than or equal to that v point when we graph it, all to the right here, that is our absolute value function. So if we look at our choices, we see that 3 is our absolute value function. Okay. Number 3 here, which absolute value function is equivalent to this one? Well, here this is saying when x is greater than or equal to 0, I have 3x. But when it's less than 0, I have a -3x. Because we're always looking for the greater than or equal to sign as being our function, we know that f of x is going to have to equal the absolute value of that 3x. And if you want, you can check to make sure that you did it correctly. So if we look here, let's pick 1 here. So we have 3 times 1, which is 3. The absolute value of 3 is 3. That's perfect. Here, let's pick a -1. -3 times -1 is a +3, which is the same thing as if we would plug -1 into here. So that works out perfect. All right, looking at this next one, we have 2 functions. We want to look for all the values where x is greater than or equal to, and that's this bottom one right here. So that means that our function f of x is equal to the absolute value of x minus 1. Okay. Last one, let's take a look. We want to again look for the ones where x is greater than or equal to the magic number. That's this one right here. So we have f of x equals the absolute value of x plus 4. Okay. All right. I know this was a lot. I'm so sorry I couldn't be there today. I hope that you learned something, right, about graphing functions. I know this was a tough lesson to do on the Chromebooks. You may begin your homework if you have time. If you have any questions, jot them down and save them for me to talk to tomorrow. Bye.